Hello children, welcome back to my channel. Now I am dealing with 7th class maths, algebraic expressions. In this we are going to start with types of algebraic expressions. In the previous class I taught you about what are variables, what are constant terms, and how to identify that it is having one term, two terms, three terms and all, and some problems basing on that we have done. Now I'm going to do about different types of algebraic expressions. The first one is monomial. Monomial. Actually, mono means single, one children. So monomial means the one which has got only one term. So as an example, let me write here examples. Examples, you can write 2x a, or you can even write uh, 5 p q, etc. This kind of anythings are called monomials. Each one is one term. This is one term, this is one term, this is one term. These are all called monomials. And second one is binomial. As the name indicates, bi means two. Binomial means it has got two unlike terms. Two unlike terms. I have told you what are like terms and what are unlike terms. Two unlike terms means, suppose you have got the same thing, 2x plus 5y, 7x square plus 3x. Anyone. These all are called as binomials. Afterwards, you have got trinomial. What is this tri? Tri means three. Means it has got three unlike terms. It has got three unlike terms. They are called trinomials. So suppose you have got example 2x square plus 4x plus 7. It has got three terms and all the three terms are unlike terms. This is trinomial. And fourth one is multinomial. We'll call it as multinomial. Multinomial means what? More than one unlike terms. Means actually these all also will come under multinomial, but 2 means bi, 3 means tri, we usually say. So you can write 3x cube plus 2x plus 2x plus 5, 3x cube I said, 3x cube plus 2x square plus 5x plus 4. You can call it as a multinomial. So these are about different expressions, children. Please write down this. Now do this sums, children. In this do this sums, give two examples for each type of algebraic expressions. So what are different types of algebraic expressions we have written? Let me write a table like here, type and then example. So first, monomial. Monomial. Monomial, I can write it as two examples they are asking. First one is 3xy and second one I can write 4y. Okay, next. Binomial. Binomial. First one a plus b I can write, and second one 7x square y plus 2y. You can write anything, you can write, children. Only the thing, but they should have two terms in it. That is called binomial. Then trinomial. Example, first one, I'll write x plus y plus z, and second one, 4x square plus 5x plus 6. This is trinomial. Next, fourth one, multinomial. Multinomial means many, I said. So, first example, I will take here a plus b plus c plus d plus e. This is multinomial I can take. And second example, if you are taking 6x cube minus 7x square plus 3x plus 5. Okay, you can take it as multinomial. So, this is the, sorry children, this is the solution for this first one. They are asking to give two examples for this example. So 2 I am giving, so plural. So two examples I should write: monomial, binomial, trinomial, and polynomial or multinomial. Next, second question is identify. The question here is in your book, identify the following as monomials, binomials, trinomials, and multinomial. So, what is this? Count the number of terms: 1, 2, 3. So, we call it as trinomial. And here you have got only one term, so this is monomial. And here you have got 1 and 2 terms, so it is binomial. And here 1, 2, 3, 4 terms, so it is multinomial. So these are the, do this sums, children, please note it down. Now we will see degree of the monomial and degree of the expression, children. For any expression, how do you find a degree? Degree is nothing but the highest power or highest exponent. How do you get of a term in an expression? This is called degree, highest exponent of a term in an expression. In an expression means in an algebraic expression, you may get monomial, you may get binomial, trinomial, or multinomial. In each term, what is the highest power? Here, highest exponent means what? How do you find out highest exponent? It is nothing but sum of variables, sum of exponents of variables. Exponents of variables. That means what you have to do, children? What are the variables that are there in each term? For variables, you will be having exponents, powers. You have to add those powers, and that will give you the degree of that particular expression. So now we are going to talk about monomial. What is the monomial degree? Suppose you have got 8x cube y. So here I am giving exponents. Exponents. What are the exponents you are having? For x you have got exponent as 3, and for y you are having exponent as 1. So total how much? 4. So degree of monomial here is 4. So monomial degree, if you want to find out what you have to take, you have to see the variables, you have to see the powers, exponents means powers, add the powers. How much you are getting, that is the degree of the polynomial. So degree of 8x cube y is 4. I hope I am clear, children. Degree means the sum of exponents of the term. If you have a polynomial, you must find out the sum of exponents of each term in the polynomial, and out of all that, which is having the highest value, that is considered as the degree of that particular algebraic expression. I think I'm clear, children. Let me talk about constant term. Constant term, suppose I have taken 9. This is constant term. We call it as a constant term because there is no variable, so its value will not alter. Its value will not change. So actually, the meaning of it is 9 into any variable to the power of 0, because any variable to the power of 0 or any term, even a big number is given to you, and they have kept 0 upon it, power 0 means value is 1. So this will be nothing but 9 into 1, that is 9. This power, this value is 1. Power of 0 means value 1. So that one I have taken here. This is 9. So what is the degree? Degree of 9 is equal to 0. So for this constant term, any constant term, degree is considered as 0. If you have any number given and ask you to find out what is the degree of it, you should say it as 0 only. So let us have a table given in your textbook. They have given here degree of algebraic expression we are talking about. Here various algebraic expressions, monomial, binomial, trinomial, polynomials are given to you, and here they have asked you to write degree of each expression. In this expression, first term is what? Second term degree, third term degree, fourth term degree. Then out of all this, what is the highest degree? And whatever is the highest degree, that is the degree of the expression. So here if you take monomial is only one term. So there is no question of having second term, third term, fourth term. So one term, what are they? 1 plus 2. So how much are you getting? 3. 3 is the degree. So here it is only 1. So highest degree is 3. Degree of the expression is 3. Now when you go to second one here what is the first expression? 3x. So it is having 1. And you have got second one also. What are the exponents? 2 and 2. Add 2 plus 2, 4. So you write 4 here. And third expression is not there. Fourth expression is not there. So when fourth expression is not there, what you will be writing? Here, out of these two, highest degree. What is the highest degree, children? Highest degree is 4. So what is the degree of this expression? This is nothing but 4. Next. Here. 4x square, 3xyz, y. How many terms are there? Tell me, how many terms are there? 1, 2, 3 terms are there. So you have to talk about 3 terms. What is the first term? Degree is 2. Second term, 1, 2, 3. Nothing means powers 1, children. So 3. Third one, 1. Fourth term is not there. So out of these 3, 3 is the highest one. So this algebraic expression is having degree. Degree of this expression is 3. Next here. 1, 2 powers. What is the first term power? 2. And what is the second one? 2 plus 2, 4. What is the third term? 2 plus 1, 3. And what is the fourth term? It is a 9. 9 is a constant term, that is 0. I have told you, no, constant term is having 0. So out of all these, which is the highest value? 4. So 4 we are taking. So degree of this expression is 4. So I hope this degree knowledge you have got, children. Degree of monomial or degree of every term is nothing but see what are the variables. Add the powers of the variables. You will be getting the value, that is a degree. Here we have got an example for monomial, binomial, trinomial, polynomial. For all these degrees, how are you taking? If you want to find out degree of an expression, see the example of as multinomial. Each term degree you have to note it down. After noting all the degrees here, each term degrees, which one is the highest? That is the degree of this polynomial. So degree of the polynomial, the higher. Usually when the definition, we usually what we say, degree of the polynomial means highest power, we will be saying. Highest power of a polynomial is degree of the polynomial. Please note it down, children. Now, children, exercise 10.2. The question is identify and write like terms. What are like terms? These are the this is 1, 2, 3, 4 problems are given to you. Here, what you have to do in each one, you have to identify the like terms and you have to write. I have written here like terms. I am going to write the answers. See here, children. This is a square. So, sorry. A square means, is there any a square here? Search properly. This is a square. Is there any other a square? No. So first we will make this as a group. That is a square minus 2a square. A square minus 2a square. These two are like terms. Is there any like term? B square is there. Is there any b square? No. This already we have taken. C square? No. 4a? No. So in this group, what we have got? Only these two are like terms. Now, second one you say 3a. Is there any 3a? Slowly you see, children. No. 4xy. That means the combination of xy we have to see. This is yz. This is zy. No. Now this is minus yz. Variables are yz. And here zy. Zy or yz, both of them are same. So you have to take these two. That is minus yz and 2zy. These two are like terms. Now let us see this. Minus 2xy square means power 2 is 2y. X is having 1 as power. But here x is having 2, y is 1. They are not same. So just to confuse you, this type of problems will be given to your children. But you should be very concentratingly observe powers. So here x is having power 1, here x is having power 2. So these two are not same. Next, y and z. Of course, we are having x and y we are talking about. Y and z we don't consider. First, we have to talk about this only. So, x and y square. The last one, x square and z. X and z combination. So, this has no like term. We have understood. Here also, x square y is there. Is there any x and y combination? No. That means this is also not having any same variables. Next you see y square z. Y square z. And is there any y square z? You don't have any y square z. Okay, 5y square, sorry children, this is 5y square x in the problem. 5y square x, x square z. So if you take y square x, that means the combination is x here, y square here. So only the thing is, in these two, they have taken the terms in inverted way, means they have changed the places of the terms. First x and then y, first y and then x. Y, x is having 1 as power, here also x is having 1 as power, here y is having 2 as power, here y is having 2 as power. That means these two are considered as like terms, the other two we cannot. So minus 2 x square y minus 2 x y square and 5 y square x. These are the two like terms. Next 7p, 8p cube minus 5p cube minus 2p, 3p are there. So 7p. Is there only p here? Yes. This is minus 2p. Here 3p are there. So 7p minus 2p, 3p are like terms. Now, is there anything else? You also heard this also, children. PQ, PQ. So, these two are also like terms. So, we have two. So, this is A and B1 is minus 5PQ and uh, 8PQ. So first 8PQ I'll write because it is first 8PQ and minus 5PQ. These are the like terms. So why are this kind of exercises given to you is, when you go in the higher classes or in the next exercises, if you don't have a thorough knowledge of like terms and unlike terms, you cannot proceed with the problem, children. So when you are observing like terms, be very careful. See, x y square x. Both of them are same, but our eye, it is not same because here x is there, here y is there. That kind of misinterpretation we will be getting because they are trying to confuse us by giving the values by exchanging their positions. But always be careful whenever you are seeing the expressions, see powers, see variables. If both of them are same, power should be same, variable should be same. Then only we will be calling them as like terms. Let the value be numerical coefficient, what we will say. Let it be anything. We don't bother. We are not bothering about numerical coefficients. What are we bothering about? Only algebraic coefficients, variables. So variables should be same, the exponents of the variables. Here each one is a monomial. Each one is a monomial and it has got two expressions, x and y and x. So expression, the power of x is 1, power of x is 1, power of y is 2, power of y is 2. So these two are in like terms. So I hope I am clear. Children, please copy this. This is first sum of exercise 10.2. Now the next problem. State whether the expression is numerical expression or algebraic expression. See children, I will write NE for numerical expression. Okay. And AE for algebraic expression. So which is NA, which is AE. NE means that is numerical expression, AE means that is algebraic expression. So what do you know about numerical expression and algebraic expressions? Numerical expressions are the expressions which contain only number. Algebraic expressions are the expressions which contains along with the number variables also. So we have to identify whether variable is there or not. If variable is there, this is algebraic expression. If only numbers are there, that is numerical expression. So here you have variable, so this is algebraic expression. And here also variable is there, so it is algebraic expression. Here only numbers are there, so this is numerical expression. And here variables are there, so it is algebraic expression. And this is only one number, so this is numerical expression. Here this is having sorry children, variables, so algebraic expression. And this is also having variables, so it is algebraic expression. Here it is only numbers are there, so it is a numerical expression. This is number with sorry, algebraic variables are there, so it is algebraic expression. Here only numbers are there, numerical expression. And here this is algebraic expression. So I hope I'm clear children, numerical expression and algebraic expression. Instead of writing that such a big uh, term every time numerical and algebraic, I have written like this. I hope I am clear to you children. Please note it down. Next problem children. Which of the following are monomial, binomial or trinomial? So by seeing the number of terms you can say it has got only one term. So this is monomial, and it has two terms. So it is binomial, and it is having one, two, three terms. So it is trinomial, and this is having only one term. So it is monomial. It is having two terms, so it is binomial, and this is having only one term, so it is monomial. This is having two terms, so binomial, and this is having one, two, three terms, so trinomial. This is having one, two, three terms, so it is also trinomial. And it is having 1, 2, 3, 4 terms. More than 3 means we will be writing it as multinomial. Okay, so this is the solution for this problem. Children, third one, please note it down. Next problem, children. Fourth one. What is the degree of each monomial? So I told you earlier, degree of algebraic expression, I said. There was a table even there for a degree, for finding out a degree of each monomial. But as I am doing for algebraic expression, I did not do that. So that kind of problem you have got it here. You have to find out a degree of each term. So here we will do like this. Sorry children. First we will see sum of exponents and we will write a degree. What are the sum of the exponents? Here it has got only one. It has got one variable exponents. It is only one, so the degree is 1. I'll write it with red pen so that you'll understand it easily. This is 1, this is 1. And here you have got 1 plus 2, because x is having 1, y is having 2. So 1 plus 2, that means how much? 3. And here you have got x as 1 plus y as 2 plus z has 2. So total how much you are having? 5. And here y is having 2 plus z is having 2. So total 4. And here m is having 1 plus n is having 1. That means 2. Here p is having 1 plus q is having 2. That is 3. So these are all the answers for this problem, children. Each monomial expressions means what you have to do? Variables. Each variable exponent, if you add, you are going to get the degree of that exponent. Children, please note it down. Now the next one, children. Find the degree of each algebraic expression. Earlier we have done this type of problem, but for this, if you do the table only, it will be convenient for you to understand. So we have got algebraic expression given. These are all the problems that you have got 6 bits. You have got degree of each term and first term, second term, third term, fourth term, how many they are having, that we will write out of this highest and degree of the algebraic expression. So here you have got two terms. First term degree is 1. Constant term already I told you 0. There is no term, there is no term, third and fourth. So what is the highest degree? 1. So degree of the algebraic expression is 1. Now second one, you have two terms. First term is having degree. See here, this is having two variables, 1 plus 1, that is 2. And this is 1 plus 1. This is also 1 plus 1, that is 2. And here, third term is not there, fourth term is not there. So, same you have got, so you have to take that only. Next, here, first term, 2 plus 1, 3. You have got 3 in the first term, and this is having 1 and 1. 1 plus 1, 2. Second term. Third term you have only 1. And fourth term 2 plus 2, 4. So what is the highest value? 4. So its degree is 4. Here, the first term 2 plus 1, 3. And here 1 plus 1, 2. You have only two terms. There is no third term, no fourth term. Out of 3 and 2, 3 is highest. So 3 is the degree of the expression. So here 1, 2, 3 terms are there. Here 1 plus 1, 2, 2 plus 1, 3, 2 plus 2, 4. That's all. So 2, 3, 4. So here it is 4. So the degree of expression is 4. Next, here it has got A, B, C should not be considered as variables, children. Here you have to consider X and X only here. So actually here, why are we not considering A, B, C as the variables? Because this is actually a general expression of a quadratic polynomial here, where A, B, C are considered to be certain numbers. Even though here you have got this, don't consider them as variables. So you have to consider only X and X. So the first one is having 2 and second one is having 1. And no third, third one is having variable, it is constant term now, so it has got 0 as the variable. So out of these three, you have got the highest degree is 2. This is the 2. So these are the answers, children. Answers for this question that is given to you. But how we have got answers, I made the table to make it clear. Here only you may get a doubt. These are also variables, no? So why should we not take? These are all, we consider them as literal coefficients, So why should we take them as constant terms? Because it is a general formula for any polynomial, quadratic polynomial, quadratic equations. Equations means is equal to 0 you will be getting. About that you will be learning in your higher classes. But at the present, you should have a knowledge that A, B, C, only in this equation, these are considered as constant terms. That is why we have not taken the powers of this. Only x powers we have taken. So please note it down. This is fifth one. Now, sixth problem, children. Write any two algebraic expressions with the same degree. So, you have to write examples. The first one that I am taking is 5x square plus 7x minus 3. Suppose if I have taken here, what is its degree? Its degree is first one is having 2. First term is having 2. Second term, this is first term, second term, third term, and degree. See, what is first term is having? First term is having degree 2, second term is having degree 1, third term is having degree power c 0. So what can I do? Its degree is 2. So second one that I am taking here is 14y square minus 10xy plus 5. So I have got three terms here. First term is having degree as 2. Second term is having 1 and 1. That is also 2. Third term is having degree as c. So its degree is also 2. So I can take this as the example. So degrees, both of them are having same degrees. They are having same degree. This is what they have asked you to say, that to uh, write two examples which are having same degree. So I hope I am clear, children. Note it down. With this, I am concluding my topic today. In the next class, I will be doing the next part.